Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, we are going to talk about probability, how you can denote probability, how you can calculate probability. So you'll be studying two different methods of finding out probability. You will also be studying the definition of probability and what exactly it is. And you will also understand how you can find out the space, the sample space of probability, as well as learn to define events using probability. So let's begin. First of all, the question is, what is probability? Probability is a mathematical description of randomness and uncertainty. It is a way to measure or quantify uncertainty. And another way to think of probability is that it is the official name for chance. So whatever you describe as a chance or a coincidence, that is what probability is. So it is a description of randomness or uncertainty, and it is used to measure or quantify that uncertainty. So this is what probability is. And in order to describe or denote probability, one way to think of probability is also that the likelihood that something will occur. So you could define probability as the likelihood that something will occur. So this is an example of what probability is. You could answer questions like, what is the chance that it will rain tomorrow? That is probability. What is the chance that a stock will go up in price? Another example of probability. What is the likelihood that when rolling a pair of dice, I will roll doubles? So that's again a probability. What is the probability that I will win the lottery? That is also an example of probability. You'll be able to answer these kinds of questions once you have learned how to calculate probability. Now, this is the notation used to describe probability because when you're performing calculations, you don't want to keep on writing the word probability all the time. So if you wish to indicate the probability that it will rain tomorrow, then you would be writing it in this manner. You will write down P and then in bracket rain tomorrow. So in this way, you can abbreviate the probability of anything. You can also decide an event A. So if you let A represent what you wish to find the probability of, then P of A, which is mentioned in this way in a bracket, would represent that probability. So this is a very simple notation of probability. Now, next you need to know the principle of probability. The probability that an event will occur is always between 0 and 1. So probability can also be 0 and 1, but many people prefer to express probability nowadays in the form of percentage. And because probability is between the scale of on the scale of 0 and 1, you can easily scale that to 0 and 100. So it's very easy to do that. And that is also something that you can describe probability in. It could be between 0 and 1, or it could be from 0 to 100 percentage. That is the principle of probability. How can you determine the probability? So there are two fundamental ways in which you can determine probability. The first is known as a theoretical method or a classical method. The second is an empirical method or observational method. Let's understand both of these methods. So the first is a theoretical method. A theoretical method is used for games of chance. For example, flipping a coin. So if you're flipping a coin, is it going to be heads or tails? That is theoretical. What is the probability of getting heads? What is the probability of getting tails? If you're rolling a dice, then what is the probability of getting 2? What is the probability of getting 3 on the dice? Then if you are spinning using spinners or roulette wheels, which are wheels that you might find in casinos where people place bets, and they say that when there's a small ball involved, you put that ball in the spinner or roulette wheel, and people will guess that this is the number it will stop on when you spin it. So based on that, people can win something. There are also lotteries where you purchase a ticket from a store, and then maybe if you win the lottery, if the number on your ticket wins the lottery, then you can uh, win. So this is another way, another theoretical method of um, finding probability. Now there are empirical methods. Empirical methods are used um, in a series of trials. When you have series of trials that produce outcomes that cannot be predicted in advance. So this is all about series of trials. The previous one was just about games of chance. This is about series of trials. Finding out the outcomes of a series of trials, that is where empirical methods of probability are used to calculate probability. Let's understand this. So if you have a single flip of a coin, it is definitely an uncertain outcome. But every time a coin is flipped, what that flip is going to be, whether it's going to be heads or it's going to be tails, is unknown till that flip actually occurs. So till the coin has been flipped and it comes back in your palm, you cannot say if it is going to be, you cannot say for sure if it's going to be heads or tails. You can find the probability of it being heads or it being tails, but you cannot say it for sure. However, if you flip a coin, a fair coin is a coin that is not biased, that, sometimes they create coins which are heavy on one side, and that's why when you flip, there's a higher chance of getting heads than tails. So if you have a fair coin, also you should not use a coin that has heads on both the sides or tails on both the sides. So a fair coin is a fair coin that has equal probability of getting heads or tails. So if you have a fair coin and you flip it over and over again, what do you expect then would be pH? Will it be exactly 0.5? pH is probability of getting heads. Okay, so in other words, would you expect there to be the same number of results of heads than there are tails? Now, this is a different question. The original question, which we might want to solve using a normal theoretical method, is if you are flipping a coin one single time, then what's the probability of getting heads or tails? But the empirical method question is if you are flipping a coin several times, you're flipping the coin several times in succession, then is the probability of getting heads and tails same now that you have some results with you? So this is the type of question where empirical methods are used to calculate probability. Now, whenever we talk about probability, we always need to define a sample space. So what is a sample space? Let's take some examples. If you toss a coin once and then if you record whether you got heads or tails, the possible outcomes of this experiment will be H, T. It is a set of H, T. So H, T is the sample space for tossing this coin, tossing one coin once. Now, the second type of case is where you are tossing one coin twice. Now, what is the sample space? So list out all the possible outcomes, which will be H, HT, TH, and TT. So these are the possible outcomes of tossing this coin twice, tossing one coin twice. So the sample space in this case is the set given over here. The third possibility is you are tossing one coin 3 times. Now, what are the possible outcomes? So these are the possible outcomes. You can have H, 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 all the 3 times you got heads. You could have T, H, H, one tail. The first time you got tail. Now in this, the order definitely matters. Okay, because you'll see other triplets like this where T is coming once, but the position of T is different because here it means T is appearing in the first toss. Whereas in another example where we've written HTH, there T is coming, tails is occurring in the second toss. So that way there are this many 8 possibilities when you are tossing one coin thrice. And same way the order matters in the when you're in the case when you're tossing the coin twice. So there also the order matters because you can see that we have listed out HT as well as TH. However, we do not list out HH twice. Okay, we do not list out HH twice because it's a possibility of getting 2 heads. But we do not do HH and HH. We do not do it that way. The sample space only contains HH once. So this is how you can define a sample space. Let's see one more example. If you were asked to choose a person at random and check his or her blood type in a random experiment, what are the possible outcomes? The possible outcomes here are 4 blood types A, B, AB, and O. We are not getting into the positive, negative part right now. So if you're just checking the blood types, then there are 4 possibilities. So in this case, the sample space contains A, B, AB, and O. The last thing we are going to discuss in this video are events. So if you are given a task to find the probability, then you can describe some events. For example, if you have coin tossing where you're tossing one coin thrice, then you can recall this was the sample space generated with 8 possibilities. This is the sample space. Now, using this sample space, you can define events. So what are events? You could define an event and say, event of getting no head. Okay, event of getting no H. So how many such possibilities are there? How many such samples are there? You can simply count from the list that you have, right? That there is no H in one possibility, one sample space, which is the last one. In one sample, you are getting no H. So A is an event of getting no H, and then you can find out the probability of this, which obviously would be 1 divided by 8, since there is only one such sample where there is no H. You could describe or define another event, for example, getting exactly 1 H. Once again, to calculate the probability, you'll just count the number of samples where there is at least not at least, where there's exactly 1 H. You'll count those samples, divide that by 8, the total samples, and you will get the probability. Then you have event C, which is getting at least 1 H. So this is where you want at least 1 H. So there cannot be 0 H, but there should be either 1, 2, or 3 H's. And once again, to calculate probability, you can just find out all such samples, divide that by 8, and whatever is your answer, that would be the probability. So finding out the sample space and defining events will definitely help you in your calculation of probability. So that's how probability is calculated. And in the next video, we are going to discuss a little bit more about probability, and we are also going to discuss in the videos after that what conditional probability is, where the probability depends on a certain condition. If some other event happens, then the probability of the event that you're analyzing can increase or decrease. So that is what we will be discussing in our upcoming videos, and I hope to see you there, and thank you for watching this one.